Good day, my esteemed students, viewers, and subscribers. If you have not subscribed, go and subscribe. Now, today, we are going to continue from where we stopped. And more importantly, we discuss very basic concepts in test and measurement. We talked about the concept of test, measurement, assessment, and evaluation, how they are different and how they are related. We talked about characteristics of a good test. We lay emphasis on validity. So today we are going to be talking about reliability, which is a necessary condition for validity. So when we talk about test reliability, in the general usage, when we say somebody is reliable, that means that person is doing something over time that people have seen it with him, and they can easily say, oh, that person is reliable. Let me cite an example. You can be a reliable liar. People will know that that is your hobby, and even nobody will dispute that. So it means that there is what we call consistency. What do I call it? Consistency. So when you talk about reliability, what should come to your mind is consistent. How consistent are you in doing it? But specifically because we are looking at educational tests or in the classroom, a test is said to be reliable when it is consistently measuring the same thing over time. So when you use a test to obtain an information and you reuse, it's going to be giving you almost the same thing or even the same thing. So a test is said to be reliable when it is consistently measuring the same thing over time. More simple, or in simple definition, reliability of a test refers to the degree of consistency to which a test is measuring what it is intended to measure over time. So there are two keywords there: consistency and over time. So when you say consistency, when you are repeating that test on the same or different, it will be giving you similar score over time. So that means more than once, or as the case may be. So reliability of a test in this situation ranges from 0 to 1, which implies that a test that has a 0 reliability, meaning that test is very, very unreliable, and a test that possesses a characteristic of 1, meaning that that test is perfectly reliable. But because in measurement we have what we call error. In classical measurement, we have true score is what? Your observed score minus your error. So T representing true score, X observed score, then your E, your error score. Just because this error is inherent, whether systematically or random, in every measurement, you cannot have a perfect reliability. That implies that a reliability of 1 may not be possible. But any reliability closer to 1 is suitable. In fact, the closer to 1, the better. Just because of this error. So measurement experts or anybody that is measuring should intensify effort to always reduce error, so that you will be closer to the true score. But error is inherent, whether systematically or random. So that's for another day when we'll be discussing error analysis or measurement errors, as the case may be. But because we are talking about test reliability, a reliability coefficient ranges from 0 to 1. The more closer to 1, the better. The more closer to 0, the worse. The more closer to 1, the better. The more closer to 1, the better. The more closer to 0, the worse. Just because we have already said in our previous edition that reliability is a necessary condition for validity. So any test that is closer to 1 is more reliable, then it will have more tendency to be valid. How do you now determine whether a test is reliable? There are various measures to determine reliability of tests. When I say measures, it can be method or approach that you can use to determine whether a test is reliable or valid. One of the approach that is used to determine whether a test is reliable or valid is what we classify or categorize under measure of stability. So we have methods to determine reliability. We have measure of stability. Measure of stability. The word stability here shows that you are trying to see whether the scores obtained from a repeated measure usage of a test is stable over time. And under measure of stability, we have what we call test retest method of reliability estimation. So some explanations around that may look at test retest reliability separately, but it is fundamental for us to know that test retest is a measure of stability. You are trying to see whether those scores are stable over time. So we do what we call test retest reliability evidence. So what do we mean by test retest? So under measure of stability, we have test retest reliability. Just like the name implies, you have a test and you use it again to determine whether you will obtain same or similar score. You are administering the same test. That is very important. More than once, specifically twice. When I say more than once, it can be more than 2 times, but you have to be comparing 2 occasions. So if you administer it 4 times, you are comparing first time to second time to third time to fourth time, first time to third time, first time to fourth time. It is comparison of 2 administration, but at least you are using the same test more than once. That's test retest reliability. So the keyword here is same test administered twice. Another measure of reliability is what we call measure of equivalency. This equivalency, another word they call it parallel form. Parallel form reliability. But before I explain that, let me specifically tell you that when you are doing test retest and you obtain score for administration number 1 and administration number 2, that implies that you are going to be correlating the 2 score to obtain a coefficient. And in statistics, because those 2 scores are continuous in nature, you will correlate the 2 score using Pearson product moment correlation, PPMC. So you are going to be obtaining a coefficient, and that coefficient will now serve as your test retest reliability coefficient, which if it is closer to 1, it is suitable. If it is closer to 0, it is worse. So, but we are talking about measure of equivalency or parallel form. When you are interested in establishing equivalency of a test as a measure of reliability, it then means that you are having two tests and you want to determine whether those two tests are similar. That's why they call them equivalency. So if you administer it to the same set of students, you want to see whether they are measuring the same thing and they are related. Let me give you an example. There was a time one examination body in Nigeria conducted parallel form tests. You have type A, type B, type C, type D. They have established equivalency before they use it as a standardized examination. If not for the fact that they have established equivalency beforehand during standardization process of test development stage, they will not be able to compare all the scores obtained by various students who have attempted different types at the end of the day. Because anybody that have attempted type A will not be able to compare them with type B, type C if they are not equivalent. But because they have established parallel form equivalency, anybody that is doing whether type A, type B, type C and type D, they are going to be judged because those scores are what? Equivalence. Just because they are related. So equivalency is trying to establish whether scores obtained from two tests or items in two tests are similar. So this one is trying to see whether the two tests that you are comparing are related or similar. Unlike test retest that is trying to see whether the scores obtained from the two tests are consistent, are stable. Another measure that you can use is what we call measure of internal consistency. Measure of internal consistency. Just like the name implies, internal. That is the key word that you have to hold. You are looking within. Unlike test retest that you are comparing the same test twice, equivalency, similar tests, whether they are related. This one is internal. That means you are looking at just one test and you are administering that one test once, but you are now trying to look at within whether the test internally is reliable. How do you go about that? Under measure of internal consistency, we have what we call split half method of reliability estimation. Split half. You have a test that contains 10 items. When we say items, we mean questions. And you want to establish internal consistency. Split half. You can divide it into 1 to 5, 6 to 10, or 1, 3, 5, 7, 9, 2, 4, 6, 8, 10. And correlate scores obtained from those two halves and see whether they are related. In that case, you are using one test, but you are splitting it into two to determine internal consistency. So split half method or evidence approach is used to explore internal consistency. Another way is what we call Cronbach alpha. The Cronbach alpha method is also used to establish internal consistency, where you look at inter-item correlation, how an item is related to the total item, and how an item is related to the total item using some statistical approach, Cronbach alpha. We also have what we call ordinal alpha, but that is another thing entirely. We also have what we call Kudar-Richardson method of estimation. Kudar-Richardson is used to establish internal consistency. We have two main types of Kudar-Richardson. Kudar-Richardson 20 and Kudar-Richardson 21. Kudar-Richardson 20, just like the name implies, is used to establish internal consistency for multiple choice. Kudar-Richardson 21 is used to establish internal consistency for essay items. Kudar-Richardson 20 is suitable for multiple choice quadratic 21 is suitable for essay item. I have to explain this basically because quadratic 20 where we have in the formula for quadratic 20 we have P and Q. P is the item that you got correctly, Q is the one that you got wrongly, and because they are scored dichotomously 1 and 0, so easily you can compute and find whether they are internally consistent for multiple choice. But for essay, it will help you find the average or the mean of the scores, and it will establish internal consistency using quadratic 21. All these are measures of internal consistency. Another measure or method rather that you can use to establish reliability is what we call Interrater reliability. Interrater reliability. This Interrater reliability is used to establish reliability when you are rating the suitability of a test. You give it to different raters who are experts. For example, subject matter experts or test experts to rate the quality of the test so that you can see whether every rater there is a convergence of opinion as regards the quality of the items on the test. So when you are doing inter-rater reliability, you give ratings to items and you give raters, let's say 5. You will now look at out of 5 raters, how many of them are saying this item is good? That is inter-rater reliability. That's an aspect of inter-rater reliability, trying to establish whether those items are relevant to the content you want to test. Inter-rater reliability. Another aspect of inter-rater is that when you score a test, you give it to other persons to also score, to see whether the scores they will also assign will also be similar or different. So if you are scoring a particular test, an examination body in Nigeria will score and give it to other ones to also look at it and score using their green pen, while the final person will check. All this is to establish inter-rater so that a rater error may be corrected by another rater. Or on the average, if you are looking at inter-rater, on the average you will know that there is plus or minus, all of them are rating in the same direction, following a particular guide to score. If one is now giving a high score and the one is giving a low score, it then implies that there's a problem. So when you are establishing reliability, it's either you are using measure of stability, test retest, equivalency, internal consistency, or inter-rater reliability approach. However, all these are classical test theory approach to establishing reliability. Though I only mentioned the fact that we have another approach to establish reliability. We have the item response theory approach to establishing reliability, or we have the generalizability theory approach to establish reliability and dependability of tests. These two approaches are different from classical test theory approaches, which are common and basic and fundamental. So they are categorized under empirical reliability evidence, which can be explored in other editions. But fundamentally, these are the basic approach to establish reliability. I hope you have learned something new. If you have questions, you can use the comment section. Your questions will be responded to. Thank you for listening. I wish you all the best.